Okay, so here's a problem that combines a few concepts that I wanted to review as well. Inclined planes, pulleys, as well as equilibrium conditions. So the problem asks us to calculate the angle of the inclined plane such that the pulley system is balanced with no movement. Okay, and I want to start by talking about equilibrium. When's a situation where the net force acting on an object is equal to zero? That's an equilibrium situation. And that would occur when there's no movement, when my velocity is zero, or if I'm traveling at a constant velocity. So this is a really, really important relationship to know. Okay, and then in this problem, I have a pulley system. You had practice problems on pulley systems and your inclined plane. So we need to be able to set up an equilibrium that would allow us to calculate the angle of inclination of that inclined plane. So how would we find the net forces? The first step, as always, is to draw your free body diagram. Okay, so I have the force of gravity acting on that object on that side of the pulley. I'm going to call that the force of gravity 1, okay, which is going to be counterbalanced by the resultant force acting on that 1 kilogram object. Okay, so my net force is going to be the force of gravity by the counter mass, called force of gravity 1, minus my resultant force on that 1 kilogram object. It must be equal to 0 if they're not going to be moving. Okay, so if I rearrange this equation, Fg1 is equal to my resultant force. Okay, and that would allow me to calculate what I need to calculate. So 0.5 kilograms times 9.81 meters per second squared is going to be equal to, well, how do I calculate that resultant force? Do you remember the formula from the last question? It would be 1 kilogram times 9.81 meters per second squared. I'm going to move this over here. Okay. Times sine theta, the angle of inclination of that ramp. And now what I can see in here is that my acceleration of gravity is going to cancel out. It's on both sides. So 0.5 kilograms divided by 1 kilogram is equal to sine theta. So 0.5 is equal to sine theta. And if I do that, I will see that my angle is going to be equal to 30 degrees. Okay, so one thing that I don't like what I did in this problem, even though I got the answer right, okay, it's a 30-degree angle. The one thing I don't like is that I quickly jumped into plugging numbers into a formula and I skipped the algebra. Okay, so if I would have went back and I would have written, I'm just going to erase this line here. If I'd go back and I would write mg, I'm going to call that m1, is equal to m2g sine theta, that's my resultant force, I'd be able to then see that the acceleration of gravity would have canceled out, just to simplify things without writing numbers in there if I don't have to, okay? And that's how we would apply an equilibrium to solve this situation, okay? So the equilibrium allowed me to set up the algebra to be able to calculate the angle.